volumes of surface areas, volumes and surface areas of what? Cones, okay? So volume, number of cubic units on the inside, surface area, number of square units on the outside, okay? Really two formulas to kind of look at today. Central question today, how can you find the surface area and volume of a cone? All right? It's really two formulas we're going to deal with today. So goals for answering that question, who wants to read those for me?
Goals?
Yep.
Find surface areas of right cones, find volumes of cones, and find use volumes.
Okay, so we're going to look at surface area and volume of the cones today, and then we're going to use that. So here's what we need to understand, kids. A cone. Does everybody understand what I talk about when I have a cone? Okay. First term up here is a lateral surface of a cone. Okay, lateral surface of a cone consists of all segments that connect the vertex with points on the base and the edge of the cone. Basically, the lateral surface is this rounded part up top, and then the round part at the bottom is my what? Base. Okay. Cone is a solid or hollow object which tapers from a circular or roughly circular base to a point. So like from this circular base, everything heads to a point from that edge. Okay, so you know what a cone is. A net. Volunteer to read net for me.
A two-dimensional pattern that can be folded to form a three-dimensional figure.
Okay, so if I folded this up, what would this form? If I fold all the triangles up, it would form a, specifically what kind of pyramid? Square pyramid, okay. And now we've talked about composite solid here, kids. A composite solid is a solid composed or made up of two or more solids or volume. Like this one right here, it looks like you have a cube, and what did they choose to take out of it? Cone. So there's like a cone part missing from that cube, and that would be a composite solid. And we'll talk about things like that today. But I don't think there's anything here vocab-wise that's too tough. So again, our essential question, how do we find the surface area and volume of a cone? And here are our goals today. That's really it. All right? Not too tough today. Ready to roll? Okay, let's check this out. Guys, core concept. First core concept we have that I think is pretty important here. Surface area of a what?
Right cone.
Okay, it says the surface area of a right cone S is S equals what? Pi r squared. That's like the area of a what, kids? That's this circular bottom right down here. That's this circular bottom right here. This is the pi r squared here. This is my pi r squared right in there. Okay? And then plus pi rl. Pi rl is that part on the outside that makes the cone shape. Okay? So the pi r squared, this is like my base, and this is like your lateral surface, they call it. And if I can find the area of the bottom and find the area of the lateral surface, what am I going to do to find total surface area? Okay, formula for this, pi r squared plus pi rl, where r is the what? That makes sense. And L is the what? Ooh, we get to use a slant height finally. That's exciting. Okay, let's see if we can't figure out example 1. Guys, finding surface area, and it makes sense. Isn't the slant height on the surface of a cone? Okay. Find the surface area of the right cone. Let me blow this up, kids. Okay, surface area. I don't expect you to memorize the formula, but I think with some practice it'll become easy for you. Surface area S. What's the formula again, kids?
Pi r squared plus pi r.
All right, let's plug in what we know. Kids, do we know the radius to plug in? Okay, so my surface area S will become pi times 5 squared plus pi times what? How about L? L is 12, isn't it? What? That's the regular height. That's the vertical height. When I'm doing surface area, I want which height for a cone?
Slant height.
The slant height, okay? So L would be right here, wouldn't it, kids? How are you going to find L?
144 minus 25.
do you want to minus here?
5
No, you
squared
add
plus
squared.
12 squared.
Yeah, you got to add because we have both legs, don't we? Now, if I had to say, how do you find L, I'd go look for Hookham in the hallway. And see if you can find, oh, 13. L Hookham. I wish my name was one letter long. Okay, not funny. I get it. Good thing I don't
You
have.
tried.
I tried. Too early?
That's all that matters.
Is it too early? On a rainy day?
Nah, I'm good, right?
I love the
You
rain.
should try to come up with clever jokes about my name. I'll be
Sunny.
impressed if you can get one that I haven't heard.
The weather is not sunny today. Oh,
Ha
shoot.
ha ha! You better laugh and start to funny.
You make me happy when skies are gray?
Yeah, with that.
Okay, yeah, you can't do one with her name because they've all been done.
Actually, who was that? Allie? Harvey did one that I've never heard before.
What?
I can't
What was
remember what it was.
I'll have to ask
That
her.
means it wasn't good enough.
Yeah, guys, we'll go back up here. By Pythagorean theorem, what's the lateral surface equal? So what do I have to plug in for L over here? So what I would suggest, kids, maybe do this in 2 steps. Somebody give me pi times 5 squared first, and we'll go nearest 10th on this. How's that sound?
78.5.
78.5. Somebody run pi times 5 times 13. 1020.
1020.5.
Is that what everybody gets? That seems kind of high to me.
Yeah, I 204.2.
Yeah, that's what the frick? How did I get such a large number?
I don't know. I think you went 5 squared times 13.
Yep.
Okay. So what was it? 204 point what?
2.
What are you going to do with those two values to get your total then?
Add.
So that would be what? 282.7? And we're talking area, so this would not be cubic units, this would be square units, so square inches. Okay? So that's what we would have there. Now guys, I want to show you something here quickly. I want to show you kind of an alternative to this, because they may ask you to leave an answer in terms of pi. I'm not sure if they will or not. But let's just talk about this part right here in this set again. What's 5 squared, kids?
25.
Do you agree that this is like 25 times pi?
Yeah.
One way to express this would be like 25 pi. What's 5 times 13 over here?
65.
Guys, if you have 25 pi and 65 pi, doesn't that add up to equal 90 times pi? Okay, another way to leave that answer would be 90 pi. And check it. Somebody take 90 times pi for me and tell me if we're close to that 282.7 mark for area. Okay. So do you see kind of what I did there also? I kind of look at this mentally and say, okay, well, this is 25 pi over here on the left. This is 65 pi. I know if I add them, I've got 90 pi. So if they would ask you to leave an area in terms of pi, how would you express that? Okay, you understand the two ways there? Okay, surface area for a cone, a right cone. What's this formula?
S equals
Pi r squared plus pi r L, where we know r represents a radius. That's nothing new. But today L is going to represent not a vertical height today, but a slant height. Cool with that? All right. So that's how you find what, kids? Okay, so we also wanted to look at finding what else? Okay, we'll look at finding volumes of cones. And here's another core concept. It says the volume of a cone. Think of it this way. Isn't a cone a pyramid for a cylinder? And if the volume of a cylinder is pi r squared times height, what do you think we're going to do with the volume of a cylinder to turn that to a cone or a pyramid for a cone? Divided by 3. It's just the same thing. And that's what it says right here. The volume of a cone is equal to what, kid? 1/3 base times height, or 1/3 pi r squared times height. I think that you should highlight this or circle this one. I like using that one. Another way I would like to write this formula, and I think kids work with it a lot better, is call it volume is equal to pi r squared times the height. Now when we talk about h, where is that h? Is that on the inside or outside? That's going to be a vertical height, isn't it? L is going to be a slant height, h is going to be a vertical height, and then divided by 3 for a cone's pyramid. Or I'm sorry, for a cone's volume. So over here we have a right cone. H would represent the height, vertical height. B is going to be the area of the base, so that's the pi r squared part. Okay? So let's roll on this here, kids. Finding what here now?
Volume. So we're right.
All right. Just got to keep your formula straight. Ask yourself, what am I looking for? Surface area or volume? Well, this one here says find what?
Volume.
Okay, so my volume, here we go. I'm going to use it because I like it like this. Volume is going to equal pi r squared times height divided by 3. I like to use that one. I think the division of 3 instead of having that fraction 1/3 out front, I think kids work better that way when you go that route. Okay, do we know the radius? And I forgot to draw this in here, so maybe draw that line in there, kids. Do we have the necessary dimensions to figure out how many cubic units are in there?
Yep.
Secondly, are all the units that are linear, are they the same unit? Everything's measured how? In meters, okay? So here we go. My volume will be pi times what's going in for radius, minions? 10 to the what power? How about my height? Excellent, kids. And then we want to divide by? Good.
879.
I'm hearing 879-ish. How many want to confirm that for me? 879.6, okay?
I just like put in or comment.
And then we would go cubic what? Now on your units, understand if we're doing area, what kind of exponent do you have out there on your unit? A 2. And if it's a volume, you have a what? Okay. Guys, 2 formulas. Surface area, pi r squared plus pi r L. Volume, pi r squared h divided by 3. You don't remember them, where can you find them? They're both in the core concepts there, aren't they? Okay. Let's look at our third page together. Guess what? We're going to talk about similar solids. Okay, that was good. I'll give it that. Guys, finding the volume of what?
Similar solid.
Guess what?
Chicken butt.
Okay, you know why?
Cow pie.
Okay. It's pretty deep in here, right? I can't take the BS that you just threw at me. All right. Right? Get cow pie BS. Okay, I'm done. Gavin's looking at me like I'm some kind of a moron, which he's probably right, so I'll just stop right there. Okay. Okay. Haven't we done this before where we said, hey, here's 2 similar solids?
Yeah.
And the side ratio.
Yep.
Volume of one is known. Find the other volume. We can't find volumes unless we have what ratio, guys?
Side.
Well, we gotta have a side ratio. What do we do to a side ratio all the time?
Cubic.
Cube it to find a
Volume.
volume ratio, right?
Yeah.
So this is the same thing that we've done, guys. This is nothing new for you. We're talking about a cone A and a cone B. They are what? Says the height of cone A is 6. The height of cone B is what? Is a height like a side or a volume?
The side.
So they give you the side ratio of A to B, don't they?
Yes.
Isn't the side ratio for A to B, kids? Side of A to side of B, isn't that 6 to 2? Okay, well then you know what? They go on to say, hey, by the way, the volume of cone B is what? 18 pi cubic inches. They just leave it as 18 pi, and that's fine. Okay, what do I have to find the volume of? No problem. Here we go. If I have a side ratio, what do I need to do to it? To get a volume ratio. What is 6 cubed? What is 2 cubed? Means for every 216 cubic units in cone A, there are 8 cubic units in cone B. But in cone B, how many cubic units do they have? 18 what? Is the 18 pi going up top or bottom to complete the proportion? Going in for? This is an interesting one, kids. Just do this for me. Take the 18 times 216 divided by 8. 56.5 pi is what you could say. But now, I don't care what you really do. If I could take this right here, wouldn't this really be 18 times what, kids? Pi. Do that. 18 times pi. Got that? take that times 216 divided by 8. What do you get for the volume of A?
1,526.8.
1,526.8. Now do this for me. Pretend pi is not even there. If they write stuff like this, pretend that it's not even, shoot. Pretend the pi's not even there. Yeah, it's over here somewhere, okay? Take 18 times 216 divided by 8. 486. I guess also say, or area would equal 486. What do we choose not to work with in that? Pi. Okay, that could be either one of these answers right here. All right, either one would work. Okay. So do you see what I did there? They started out with a volume in terms of pi. We ended with a volume in terms of pi, or we also converted it to a decimal. Do you understand? If they say go to the nearest tenth, you know what to do for an answer. In your assignment. If they say leave it in terms of pi, you know what to do in terms of an answer. Okay. All right. Well, let's talk. Finding the volume of. Is there more? Did I miss something? Huh? Okay, I thought I missed something up here. Are we good on 3? I'll just back up. Are we okay on 3?
Yeah.
And if I would have done this correctly, I would have said these were cubic inches on that, okay? So make sure you just double check yourself on units. I'm not going to get too picky about it because I'm worried about process and not picking points apart. Okay, example 4 concerns me. All right, not so much the volume, but the surface area. Okay. First of all, kids, describe my composite solid that we're working with. It's like two cones, one on top of the other. Okay. So would the volume of the cones just be the volume of the top cone plus the volume of the bottom cone? That's how much they can hold? Okay, let's do that. The volume's pretty easy. I like this one. Let's work with the top cone first. Okay, we're doing volume, so what formula do I want, kids? Pi r squared times height divided by. Okay, do I have the proper height and do I have the proper radius? Okay, no problem. Here we go. Volume of the top would be pi times what?
3.
Times the height divided by. Okay, tell me what that number is. 37.6. I'm going to bank that, okay? Then the volume of the bottom cone, how would you find that? Same thing, but instead of having 4 as a height, you would have 8 as a height. So pi times 3 squared times 8 all over what? 75.3. Okay. How are you going to get your total volume? So right here you add them. 37.6, 75.3. I don't know. 112.9. Is that right?
Yeah.
Cubic.
Yeah.
Okay. So volume's pretty easy, right? We just found the volume of 2 cones and put them together, didn't we? So I get concerned about the next one. What's the next one say? Surface area is only the area on the what? So, go back to your surface area for me. Core concept, first one.
The formula?
Yeah.
As it is.
It's pi r squared plus what? But that pi r squared represents the base, which is circular, right? Is that circular base part of the surface, or is that buried inside now? Think of the parts that you're going to see just on the outside surface. Are you going to see any of that circular part that's part of the base?
No.
Aren't you going to see two lateral sides of a cone?
Wait,
So
what?
won't the top be pi RL?
Once the edges of the base come?
Well, but you can't see the area of the circle in your low, can you? It's kind of like taking two cans and putting them together. Well, give me two cylinders here. Maybe I can do this. Ah, I have an idea. Get my pods out. You okay if I threw these in the hallway too? Would that be okay?
Funny.
Alright, here's the deal. Does this have a surface area? Does this top have a surface area to it on the outside right now? And does this one have top to it? Well, when I put them together, do you see that surface area anymore? The only thing I do is consider the surface area on the bottom and the side. Bottom and the sides. When I put the two together, don't these two surface areas,
I can see the top inside of it.
don't they go away from each other?
I have nothing to do with it.
Can you still see the edges though?
It's not just coffee, it's donut shop, vanilla cream, tough, flavored stuff. It's good. You guys get what I'm talking about? The only thing we're gonna see is like these lateral surfaces, right? I can't use the pi r squared, so let's talk about the top. The top, all I can do is just pi RL because we don't have the base exposed. Guys, what's the radius of the top part on this outside edge? 3. What's my lateral height? Could you find this? Yeah, it's a 3, 4. Yeah, isn't the L going to be 5 right here?
Yeah.
So this is 3, 5, and pi, right? Okay, how about the bottom? I have the radius of 3. Do I have the lateral height here again? Or do I have to find it? Okay, so what's 3 squared? What's 8? Or I'm sorry, yeah, what's 8 squared? So what's 964 add up to? Somebody root 73 out and tell me what that is to the nearest 10th. 8.5? So L is 8.5 here. So I would find the lateral part of that cone, pi times 3 times 8.5. Somebody have the first number up here for me?
47.1.
Top is 47.1 square units. Bottom? 80 point, I'm sorry.
1.
Okay, what are you going to do with the 2 to get a total surface area? 80.1, 47.1, what do you have?
47.
It's a surface area, kids, so 127.1.
Yards.
Okay, square yards here. Why didn't I have pi r squared involved in this, kids? The circles aren't part of the outside there, are they? Okay, so you just got to use part of the formula there to find that surface area. All right, kids, questions about the notes. Really, how many formulas today that are new? You're just determining between surface area or volume, aren't you? Okay, and everything's going to be related to cones, right? Cones specifically. I've got a short peer eval. I'd like to see that come across my desk before you leave. I'm going to send out the new online. Just don't forget the online from 11.5. Stuff we graded today. Make sure I have that in tonight. What questions do y'all have?